Good morning, students. Today's class we are going to continue exercise 3.6. You can take page number 63 in your NCERT textbook and you can refer the questions from your textbook. Okay, children? Today we are going to continue exercise 3.6. Okay, do you remember the HCF problem which I have taught you in the last class? Yes, what is meant by HCF? Highest common factor. We are going to find the factors of those two numbers and we are going to find the common factors between these two numbers, and in that which is highest, that we are going to take as HCF. But for small numbers all, we can easily find the factors of those numbers and common factors. But if it is a larger numbers, it is difficult, okay, to find the factors, and because sometimes you may miss any one of the factors, so that might be a difficult task. So what I am doing is, for finding the HCF, we are doing the prime factorization of both the numbers separately. Then I am going to multiply the common prime factors of those two numbers, where I will get the HCF. Okay, listen. The same thing we have done in our last class. I am going to do the prime factorization of two numbers separately. Okay. Now, it comes in third table because 2 plus 7, 9. 9 is a multiple of 3. So, it comes in third table. 9 3s are 27. Next, 3 3s are 9. 3 1s are 3. Is it? Next, in third table, because 6 plus 3, 9. It is also a multiple of 3. 3 2s are 6. 3 1s are 3. Okay, 3 2s are 6. 3 1s are 3. Next, third table, 3 7s are 21. Seventh table, 7 1s are 7. So now, prime factorization of, or you can write prime factors of. Prime factorization of 27 is what? How you will write the prime factorization of 27? 3 into 3 into 3. Next, prime factorization of 63 is how much? 3 into 3 into 7. Is it? 3 into 3 into 7. So, how you will find the HCF now? I will multiply the common prime factors of those two numbers. So, actually this 3 and this 3 can be circled because common. This 3 and this 3 can be circled? Yes, because it is common. Can we circle these two? No, it is not same. So, now I am going to multiply the common factors. Instead of these two, I have written only 1, 2. Instead of these two 3's, I have written only 1 3 here. Instead of these two 3's, I have written only 1 3 here. Now 3 3's are 9. So what is our HCF value? 9. HCF usually we can find by this way. Okay, this will be easy for you to do the calculation. But instead you can find the factors of 27 and you can write all the factors of 27. Then 63, you can find all the factors of 63. It is quite difficult. In that you can circle the common factors. Then I will write the common factors. No, in that common factors, which is your highest value, that is your HCF. You can do like that also, but this will be the easy one for you. Okay. Then we can easily find the answers without any correction, without any mistakes. Okay, my dears. Next is your G question. In this G question, what are the values we have to find the HCF? 70, 105, 175. Is it? So, is it easy for us to find the factors of 70, factors of 120, 105, factors of 175? It is very larger number, right? So, it will be easy if you do this type of calculation and find the HCF. So, HCF means you have to do the prime factorization separately. Just keep this in your mind, okay? Actually, E and F sum is your homework, children, okay? I have to do the prime factorization separately. Now, in 70 alone, I am doing fifth table because prime factorization, no, you have to use only the prime numbers. 5 ones are 5. Remainder 2. Up at 0 will become 20. Is it? 5 fours are 20. 5 ones are 5. 7 minus 5 is 2. So 0 will become 20. 5 fours are 20. Now next. The last digit is an even number, right? So it comes in 2 table. 2 sevens are 14. 7 ones are 7. That's all. Next, fifth table. 5 twos are 10. 5 ones are 5. 3 sevens are 21. 7 ones are 7. Next, fifth table. 5 threes are 15. Remainder 2. 5 will become how much? 25. 5 fives are 25. Next, 5. 5 sevens are 35. 7 ones are 7. Okay, that's all. All the prime factorization has got over. So what you will do? Prime factorization of 70 is how you will write? 5 into 2 into 7. You won't write 1. Why? 1 is not a prime number. So you don't use 1 in the prime factorization. Next. Prime factorization of 105. 5 into 3 into 7. 5 into 3 into 7. Next. Prime factorization of 175. 5 into 5 into 7. Now, how you will find the common prime factors of these three? See, listen. It should be common in all the three. Like 5. If I take the number 5, it is common in all the three numbers. So, I am circling it. Whether 2 has any common factors? No. 3? No. 5? No. 7. It is common in all the three numbers. Okay. So, now HCF how you will write? 5 into 7. Product of the common prime factors. Product means what? Multiplication of the common prime factors. 5 sevens are 35. Is your HCF. Understood, children? Next is your H question. Okay. 91, 112, 49. Okay. This is also somewhat bigger value. So we can do the prime factorization separately. 91, 102, 49. Yes. In which table this 91 will come? 2 table? No. 3rd table? 9 plus 1, 10. 10 is not a multiple of 3. So it does not comes in 3rd table. 5th table next. No. 7th? Yes, it comes in 7th table. 7 ones are 7. Remainder 2. 9 minus 7 is 2. 1 will become 21. So 7 threes are 21. Listen. 7 ones are 7 da. 9 minus 7 is remainder 2. 1 will become 21. So 7 threes are 21. This 13 is a prime number. So we can write like this. 13 1. 13 ones are 13. Okay. Next. We are going to do this 112. It comes in 2 table because last digit is 2. Right. Is it? Last digit is what? An even number. 2 fives are 10. Remainder 1. 6 twos are 12. Next again in 2 table. 2 twos are 4. Remainder 1. 5 minus 4 is 1. 6 will become 16. 8 twos are 16. Next in 2 table. 2 ones are 2. 2 4s are 8. Again in 2 table. 2 7s are. Next is 7 1s are. Listen children. 2 5s are 10. 11 minus 10 is 1. Above 2 will become 12. 2 2s are 4. 5 minus 4 is 1. 6 becomes 16. 8 2s are 16. 2 1s are 2. 2 4s are 8. 2 7s are 14. 7 1s are 7. Now 49. Actually, have you heard this word, this number 49? Yes. 7 7s are 49. 7 1s are 7. Okay. Now shall we write the prime factorization of 91, 112, 49? Yes. Prime factorization of 91 is equal to 7 into 13. You don't want to write this 1. Why? It is not a prime number. In prime factorization, you don't use the number 1 here. Prime factorization of 112. 2 into 2 into 2 into 2 into 7. 1 2 3 4. 1 2 3 4 2s are there into 7. Okay. Next. Prime factorization of 49 is equal to 7 into 7. Now you understood how I have written? Yes. Now what shall we do? We can circle the common factors, common prime factors. Is there anything common? Yes. 7 is common in all the 3. Okay, 7 is common in all the 3. Is there any other thing common? No. So what is our HCF now? HCF is equal to 7. If any number is there, you will multiply those two numbers and you will write. Since we have only 7 as common factors, you can write HCF as 7. And if there is no common prime factors, what you will do? The HCF is 1. Okay. Next IC problem. 18, 54, 81. So this also we are going to do the prime factorization separately. Okay. Now into table. 9 2s are 18. 3 3s are 9. 3 1s are 3. Is it correct? Yes. Next again in 2 table, because last digit is 4. It is an even number. 2 2s are 4. For 5 minus 4 is 1. 4 will become 14. 7 2s are 14. 3 9s are, because it comes in third table. 2 plus 7 is 9. But it comes in third table. 3 9s are 27. 3 3s are 9. Sorry, 3 3s are 9. Then 3 1s are 3. Okay. Next. 8 plus 1 is 9. It comes in third table. 3 2s are 6. 8 minus 6 is 2. 1 will become 21 now. 3 7s are 21. Next. 3 9s are 27. 3 3s are 9. Okay, now we have found the prime factorization of these numbers, right? So what shall we do now? Prime factorization of 18 is equal to 2 into 3 into 3. Is it correct? 2 into 3 into 3. Prime factorization of 54 is how much? 2 into 3 into 3 into 3. 2 into 3 into 3 into 3. Next. Prime factorization of 81 is how much? 3 into 3 into 3 into 3. 3 into 3 into 3 into 3. Now what shall we do now? We should circle the common prime factors. 3 common in all the 3. and this 3 also is common in all the 3. Then check whether 2 is common. What 2 is there in only 2 numbers. It should be in third also. Only then you can circle it. But it contains only in 2 numbers, so you don't want to circle it. Likewise, it is there in 3 is there in only 2 numbers. It is not there in third number, so you can't circle it. So what you will do now? HCF is equal to 3 into 3, because this 3 I will write 1 times, this 3 I will write 1 time. 3 3s are 9. So HCF is what? 9. Understood, children? Next, J question. So what you will do? 12, 45, 75. 12, 45, 75. What you will do? You are going to do the prime factorization of these individual numbers. 2 table, 6 2s are 12. Then in 2 table, 2 3s are 6. In third table, 3 1s are 3. Okay. Next, 5 plus 4 is 9. It comes in third table. 3 1s are 3. 4 minus 3 is 1. So 5 will become 15. 5 will become what? 15. 5 3s are 15. Next, it comes in fifth table. 5 3s are 15. 3 1s are 3. Next, 75. It comes in fifth table, right? Yes. 5 1s are 5. Remainder 2. Because 7 minus 5 is 2. 25. 5 will become what? 25. 5 5s are 25. Next, 5 3s are 15. Next, 3 1s are 3. Okay. Now all the prime factorization has got over. Next, what you will write? Prime factorization of 12 is equal to 2 into 2 into 3. 12 is what? 2 into 2 into 3. Next, prime factorization of 45 is equal to 3 into 5 into 3. 3 into 5 into 3. Next, prime factorization of 75 is equal to 5 into 5 into 3. 5 into 5 into 3. Okay, now I have written all the prime factors. Now shall we circle the common factors of all the 3? Yes, only this 3 is common. Is there any other common thing? No. So what is our HCF? Only one number is there, so you can directly write that number. So HCF is what? Number 3. Understood? Second question. Okay, you can write this question in your textbook itself. Okay, children? What is the HCF of 2 consecutive numbers, 2 consecutive even numbers, 2 consecutive odd numbers? Okay, we are going to find the HCF of 2 numbers. Okay, I am just taking 4 and 5. Okay, 4, 5. I am just going to take a 4 and 5. Because 4 and 5 are 2 consecutive numbers, right? 4 next 5. Appo 4 and 5 are 2 consecutive numbers. Now shall we find the LCM of, we can find the prime factorization of 4 and 5? Yes. 2 2s are 4, 2 1s are 2. Next, 5. 5 1s are 5. So what are the factors of 4? 2 into 2. Prime factorization of 4 is 2 into 2. What is the prime factorization of 5 is? 1 into 5. 1 will not come. So 5. Okay. So is there any common factors between these two? No. If there is no common factor, what will be our HCF? HCF is 1. Okay. Always the HCF of 2 consecutive numbers is 1. Keep it in your mind, children. Always, even if you take 1,000, HCF of 1,000 and 1,001, the HCF will be only 1 because there won't be any common prime factors. Okay. So what just we are saying is, the HCF of 2 consecutive numbers will be 1. Okay. Even 2000, 2001 also the HCF will be 1. Okay. Next, even numbers. I am going to take two consecutive even numbers. What are the two consecutive even numbers? 4, 6. Correct? After 4, what is the next even number? 6. Because 5 is an odd number. You should not take that 5. 4, 6 is the two consecutive even numbers. 4. 2 2s are 4, 2 1s are 2. Next 6. 2 3s are 6, 3 1s are 3. So what are the factors of 4? 2 into 2. What are the factors of 6? 2 into 3. So what is the common factor of 4 and 6? 2. Right. So what is our HCF now? 2. Okay. Always the HCF of two even numbers. It can be 2000, 2002. 3000, 3002, because after 3000, what is the next even number? 3002. The common factor between these two will be always 2. Okay, but between the highest common factor of two consecutive even numbers is always 2. You can write it in your textbook itself. Odd numbers. 7, 9. Both are odd numbers, right? After 7, 9. Because 8 is an even number, so don't want 8. 7, 9. What are the factors of 7? 7 1s are 7. 9. 3 3s are 9. 3 1s are 3. So what is the prime factorization of 7? 7. Because you should not include 1. 9. 3 3s are 9. You should not include 1. What is the common factor of these two? Nothing it is there. So what is, if nothing it is there, what is our HCF? 1. So HCF of two consecutive numbers is always 1. HCF of two consecutive even numbers is always 2. Even, keep it in your mind. Even is a multiples of 2, right? So that HCF will be 2. Odd numbers, the HCF will be always 1. Just this is all the rules. Okay, children? This is your third question. What is the third question? HCF of co-prime numbers 4 and 15 was found as follows by factorization. How they have find the HCF of 4 and 15? By using prime factorization. How? I will do the prime factorization of 4 and 15 separately. 2 2s are 4. 2 1s are 2. 5 3s are 15. 3 1s are 3. So what are the factors of 4? 2 into 2. What are the factors of 15? Prime factorization of 15. 5 3s are 15. So HCF of two co-prime numbers 4 and 15 was found as follows by factorization. We have did the factorization and we have found the HCF. How? 4 is equal to 2 into 2 that they have given. 15 is equal to 5 3s are 15. Since there is no common factor, is there any common factor between these two? So HCF of 4 and 15 is 0. They are saying what? HCF is 0. Is the correct answer? No. Why? Why? There is no common factor. So what is our HCF will be? 1. If there is no common factor, what will be our HCF? 1. So the answer is wrong. No, the answer is wrong. If not, what is the correct answer HCF? The correct HCF is 1. Okay, what is our correct HCF? The correct HCF is 1. This question also you can write it in your textbook. Okay, children? Today's class we have discussed how to do the HCF of 2 or 3 composite numbers. Okay, we will do the prime factorization separately and we will find the common prime factors in those two and we will multiply that value. If there is no common factors, you will take HCF as 1. Okay, so this is what the fact we have learned today. Okay, my dear children, thank you.